words, if you had some low years, then the likelihood of the next year being a low is not 50-50. It's not 50% above the mean, 50% below the mean. It's higher than 50-50. Where like us going into a casino, the system is rigged. But it's how it's rigged, we don't know. What it is about nature that determines the memory of the river, we don't know, but we know that the river has memory. We can look, and to state it in even more everyday language, what we can do is we can look at the kind of droughts, the kind of animals that we're dealing with over the past 1,200 years, and ask an even simpler question, which is how long have they lasted? And so it couldn't be a simpler question. The lows, they last decades, and multiples of decades. So maybe 10, 20, 30, 40, 50 years. That already is very useful information, that you can use the statistics, the history of the river to say, look, we're 20 years into a drought, but these kind of events in the past have lasted as long as 50 or 60 years. So without any added complications, you can say the odds of this going on are pretty high. And you can compute these. I'm sort of waving my hands and using words. But there's a technique which physicists are familiar with, which is you can write this time series, this list of numbers, 1,200 numbers, the amount of water each year that the Colorado River supplies. You can write it as a sum of waves. And so waves of different wavelengths. And you can measure the amplitudes of these waves. This was done by a guy called Joseph Fourier, who actually did it, I found out, when he was studying climate change. That I didn't know. He didn't tell me that in England when I was studying physics, but that's why he did it, actually. And it's a unique way of measuring the amplitude of these waves that actually determine the variability. And it's the slow waves that are very important, the long wavelength ones, where it varies on time scales of decades. And those, for the Colorado River, have high amplitude. And so my subject of my talk is the memory of rivers, but I also mentioned the color of rivers. So the Colorado River is red. It's red in a visual sense because, you know, the erosion brings in the iron oxides into the river and it looks red. But it's red in a mathematical sense, in that these slowly varying waves have higher amplitude. And the reason we call it red is because if you look at visible light, say white light coming out from here, and you were to boost the low wavelength waves, the white light contains all wavelengths, you will get red light. And so it's a sort of metaphor. The Colorado River, in its mathematical sense, is red, and we can use that to actually estimate the length of the droughts and to predict, given what we know of the history, what the most likely outcome is in the future, meaning 2019, 2020, and so on. So that's the first point I wanted to make, is that the Colorado River has memories. The droughts in the past have lasted as long as 50 or 60 years. And so any policy that we make for river usage should take that into account. The reason we have to keep revising these river plans is because the people who are responsible, the stewards of the system, have not taken this into account. They've ignored this fact. They said, everything's going to get back to normal, and so no worries. But the history, you just need to look at the data. The data say otherwise. You don't have to look very far. I'm an astronomer, as you pointed out. I study galaxies and things, and just by looking at the data, you can see the droughts have lasted longer than that. So we're in these rare events.